I'm Anil Kumar sharing with you a thinking question from previous test papers on derivatives with first principle, right? So normally you may get this question as a bonus question, right? The question here is, given g of x equals to 1 over f of x, where f of x is differentiable for all x and f of x is greater than 0, that means positive. Use definition of derivatives as limits to find derivative of g dash x in terms of f of x. Part B of this question is, so we have two parts here. First one is you need to find expression for derivatives, and the second is derivative of gx is differentiable for all values of x. Correct? You can actually pause the video, answer this question, and then look into my suggestions. Now, when we say definition of derivatives as limits, we mean what? We mean that derivative of gx is g dash x, which should be limit h approaches 0 of g of x plus h, g minus g of x over h, right? So this is g. Okay, that's what we mean. Now when I say g, and g is defined as 1 over f of x, so I could write this as, let me write this as limit h approaches 0 for 1 over f of x plus h minus 1 of f of x, right? Since g of x is 1 over f of x over h, that's what it means. So we have to prove that this exists, and we have to find an expression involving f of x. That is the question. So I hope the question is clear to you now. You can pause the video and solve it. Perfect. Okay. So let's cross multiply and rewrite. So we could write this as limit h approaches 0. So when you cross multiply, you get f of x minus f of x plus h. We could write this product in the denominator, right? So h times, let me write in a bracket, f of x plus h times f of x. Is that clear, right? So we cross multiply. You could do like this also. Let's say cross multiply. Let me do it here. So you could write here as limit h approaches 0. So when you cross multiply, you get f of x over, we have a common denominator, right? Minus f of x plus h over product of these two, which is f of x plus h times f of x. Everything divided by h, right? So I've rewritten this by this. Is that clear? Okay. Now, from here, you could write it in two terms. So let's rearrange. So I'm rewriting this as limit h approaches 0. So I could write this as two parts, which is f of x minus f of x plus h divided by h, right, times the other part, which is 1 over f of x plus h times f of x, right? I could have gone from here to this step also, and all this is in brackets, right? So all this is in brackets. Is that clear? Good. So I'm just rewriting. You can say here or either way. Okay. Now, using the properties of limit, I could rewrite this as limit of h approaches 0. Now that will remind you of something. Do you see x plus h coming first? If I rearrange this, it becomes what? Negative of f of x, right? So what I will do here is, okay, so let me use two steps anyway. So we'll write f of x minus f of x plus h over h times limit h approaches 0 for this part. which is 1 over f of x plus h times f of x. Is it okay? So I've used properties of limits here. So that is a property of limit. Correct? Now what I'm going to do is I'm just going to replace this, interchange and with a negative sign. Perfect? This is what I'll do. And here, if I replace h with 0, then I get f of x whole square. So we could rewrite this as limit h approaches 0. So this is a very critical step. So I'm just taking negative outside for that function and writing this as f of x plus h minus f of x over h. Is it okay? Times. Now here, if I write h equals to 0, I get 1 over f of x whole square. This gets multiplied. Is that okay? So that is how it is. Limit of this, we can substitute 0 here and get that. Now this gives you what? This gives you what? So we could write negative outside now and we get limit h approaches 0. And the function which we have is f of x plus h minus f of x over h, right, times 1 over f of x whole square. Now this by definition is derivative of f of x, right? So what we get here is minus derivative of f of x times or divided by f of x whole square. So the derivative of the function which is reciprocal of f of x is as shown here. Do you see that? So it is negative of derivative of f of x divided by square of the function itself. So I hope that helps. This is a very important conclusion. Later, when you learn quotient rule, you will understand it could be derived from the quotient rule also, right? So later reference, quotient rule. Just to remember, right? So I hope that makes sense. So the answer is, derivative of this function is, so we can write here, right on the top here, so g dash x is equal to negative of f dash x over square of fx, right? So that's how we could do it. So I hope it is absolutely clear. Go through this proof once again. It's very important from test point of view. Feel free to write your suggestions and comments, and I hope you like it. Thanks for watching and all the best.